Good morning, CSEC math students. Welcome to another live math class. What we're going to be doing this morning is continuing our algebra. The algebra that we left off last week, we were adding and subtracting algebraic fractions. So we're going to pick up from there and maybe do a little more complicated ones than the ones that we did last week. All right, so let me allow my students to join and then we'll get right into it. In the meantime, I'm going to be setting up my fractions. And remember, we do algebraic fractions just as how we do our regular fractions, meaning we find our LCM. So we find the LCM and then we divide the denominators into the LCM and multiply that answer by the numerator, all that kind of good stuff. That's how we do. That's what we do. So let's go into it. So let's go into it. All right, so we want red and we want our highlighter. Oh, man. So let's say we have 4 and we have 9xy plus 5 7x, right? Okay, so we're starting with this fraction. So we have 4 over 9xy plus 5 over 7x. Let's call this number 1 because our scholars are going to need reference. So if they're asking a question, and those who are joining us in the chat, you are encouraged to ask questions and to tell us the answers that you get. So this is question 1. Now, in the denominator, we have 9xy and 7x. So just as with any other fraction, we want to find the LCM, the lowest common multiple of 9xy and 7x would be 63xy. So we have to, the LCM of 9 and 7 is 63, and we also have to represent each of the variables that are in the denominator. So xy is the LCM. So now we're going to divide the LCM by each denominator. So 9xy into 63xy goes 7 times. The xy's cancel each other out, and 9 into 63 goes 7. 4 times 7, that's 28. And 7x into 63xy. So 7 into 63 goes 9 times. And y is left. So it's 5 times 9y. And 5 times 9y would be 45y. And this is actually our answer because we can't simplify this anymore. We can't add 28 and 45y. You can't add a term that has a y with a constant. You just can't. They're not like terms. if we could think of a number that could go into 28 and 45 and 63, other than the number 1, then we could also cancel if we could find, but there's no number that can go into all 3, and it has to be all 3. We can't cancel these 2 and leave that one, or cancel these 2 and leave that one. So we could use 9. If we were able to do that, we could cancel these 2 by 9, or we could cancel these 2 by 7, but we can't. Whenever you have a situation where you have 2 terms at the top and 1 at the bottom, or 1 at the top, 2 at the bottom, or any number of terms with this straight line separating them, if you want to reduce it or cancel it, you have to find a number that can go into all 3 terms. So this is our answer here. All right, so let's do number 2. Number 2. All right, so again, so let's say we have 4 over PQ minus 3 over Q. Or let's put a variable here too. Let's put a coefficient of 5. So we have 5 PQ. It's not an S, it's a 5. 5 PQ, and there's a Q in the denominator here. So the LCM would be 5 PQ. Because 5, we'd have a 5 and a 1, so that's 5. And the PQ, we have to represent both variables. So 5 PQ would be the LCM. 5 PQ into 5 PQ goes 1 time. And 4 times 1 is 4. Q into 5 PQ goes 5P times. Three times 5P, that's 15P. More precisely, -3 times 5P is -15P. And that would be our answer there. So that's the first 2. So give me a shout out in the chat now. Let me hear if you understand. Let me hear if you understand. So tell me, write in the chat. If you get it, say I get it. If you don't get it, say I don't get it yet. Okay, Legende says she still doesn't get it. John says he's got it. Let me hear from the others. We're going to do more, of course. So if you haven't gotten it yet, that's all right. Jamani says he understands. Ngozi understands. Great. Najara understands. So let's go press on and do some more. So press along, saints. Press along, press along. All right. So question 3. All right. So for this one, let's say we have 4x over 12, 4x over 12y plus 8y over 10x. So 4x over 12y plus 8y over 10x. So let's find the LCM. The LCM of 12y and 10x. Let me hear what you say. What's the LCM? What's the LCM of 12y and 10x. Let me see some answers for that. The LCM of 12y and 10x. Okay, so John is giving his answer. Let me see some other answers for that. What's the smallest number? Remember, you have to give the number and the variables. So Jamani and Najara are saying 60, but what about the variables? John is saying 60xy, and that is correct. You can't leave out the letters. You have to represent each of the letters. So the LCM of 12 and 10 is 60. And then we have to represent the X and the Y. And usually we put it in alphabetical order. It's not a must, but this is just the standard way. So this is the LCM, 60xy. So 12y divided into 60xy, the y's will cancel and we're left with x. And 12 into 60 goes 5. So we're going to multiply 4x times 5x. And that's going to, so 4x times 5x, that's 20x squared. And 10x into 60xy, the x's cancel. So we're left with y, and 10 into 60 goes 6. So we're going to multiply the 8y times 6y. And we're going to be left with 8 times 6 is 48. 48y squared. So we can't add these two because one is a x squared and one is a y squared. But what we can do is we can reduce these since they are all divisible by 4. They're all divisible by 4, so we would have 4 into 20. That would leave 5x squared, and 4 into 48 would leave 12y squared, and 4 into 60 would be 15, and we're left with x and y. And that's the answer for number 3. As we go along, whenever you realize that you get it, just type in the chat, I've got it. All right, so 10a over 15b minus 3b over 8a. Tell me the LCM. Tell me the LCM for that, for these two. So we have 10a over 15b, and we're taking away 3b over 8a. What is the LCM? What's the LCM of 15b and 8a? All right, so Aiden says he's getting it a little bit. It's becoming clearer and clearer. What's the LCM, scholars? 15b, 8a. Okay, so, all right, so Chance is saying 120 AB. John is saying 120 AB. And that is correct. LCM of 15 and 8 is 120. And we have to represent both variables, so we have to put the A and the B. So 15B into 120AB, the B's will cancel. 15 into 120 goes 8 times, so the 10A times 8A, since the B is no longer there, this B cancel that B. So 10A times 8A, that will be 80 A squared. And 8A into 120 AB, so the A's cancel this time. And 8 into 120 goes 15, so we're multiplying this by 15B. By 15B. Okay. So 3B times 15B, and that's gonna give us 45B squared. Now we know we can't add A squared, we can't subtract B squared from A squared. They are unlike. We can't simplify unlike terms. However, we could cancel, since 5 can go into each of these terms. Remember, we said the only way we can reduce them is if we can find a number that can go in all 3 coefficients or all 3 variables. So we can divide each of these by 5. All right, so 5 into 80, that's 16. And we have our A squared. 5 into negative 45, that's negative 9. And we have our B squared. And 5 into 120, that's 24. And we have our AB. And this is our final answer for number 4. So have a look at it. As we go along, it should be getting clearer and clearer to you. All right, Lejande says she's still not getting it. So Lejande, are you able to identify where along the line you're not getting it? Do you get it as I'm going along? Are you getting it up to a point, and then you say, huh? I didn't get that part. Can you let me know where along the line you're not understanding? And the rest of the scholars, let me hear from you. Those who were not getting it after we've done these 2, is it clearer to you now? So we're gonna do a couple more, maybe about 4 more. So let's do 4 more. Or maybe 6 more. All right, Ajabulani is asking, how did I get the x square? So which x square? So we got this x square because it's 4x times 5x. So when we divided the 60xy by the 12y, the y's cancel and an x was left. And 12 goes into 65 times. So it's 5x we carried up to multiply by the 4x. So that's how we get the 20x squared, because x times x is x squared. So we're at now number 5. And for number 5, we have 9x plus 4y over 3p. So 9x plus 4y over 3p. All right, so likewise, we need to find the LCM. But what are we finding the LCM of? Tell me which two numbers or which two terms we will be finding the LCM of in this case. What and what? So we're asking ourselves, what is the LCM of what and what? Look at the fractions carefully. Which two terms are we finding the LCM of? Okay, so Jamani says 1 and 3. John says 3p. Listen to my question, John. Which two terms am I finding the LCM of? Najara says 3 and 1. You're almost correct. You guys, all three of you guys, almost correct. We're finding the LCM of 3p and 1. And you must be asking, where is that 1 coming from? Remember, this 9x is in the numerator. So we have to fill in the denominator there. We weren't given a denominator, so we have to put the 1. So we're finding the LCM of 1 and 3p, not just 1 and 3, 1 and 3p. And that LCM is 3p. 1 goes into 3p, 3p times. So we're going to have 9x times 3p, which is 27px, or xp if you want. And 3p into itself goes 1 time. So we'd have 4y times 1, which is 4y. So the answer then is 27px plus 4y over 3p, which cannot be simplified any further. This cannot be simplified any further. So that's our answer there. For number 6, let's say we have 13x over 20w minus 2y. So what would we be finding the LCM of? We have 13x over 20w minus 2y. Likewise, we put the 2y over 1, and the LCM of 1 and 20w would be 20w. 20w goes into itself once, so we have 13x times 1, which is 13x. And 1 into 20w goes 20w. So we're going to have 2y times 20w. And that is going to give 40 wy. So our answer is 13x minus 40 wy over 20w. And this cannot be simplified, because even though we could cancel the 20w into the negative 40w, it could go into the 13. And we can't cancel these two terms or these two terms. It has to be all three. Whatever you're using to cancel, has to be able to divide into all three. It has to be a common factor of all the terms. So let's go to number 7. So we're going up to 10. All right, so number 7, let's say we have 11x minus 3y over 8p. So we know when we have our fraction like this, the best thing to do is to balance things out by putting the one that doesn't have any denominator, just put it over 1. We haven't changed the number in any way because to divide by 1 would give you the same number. So we haven't changed the value of the term. We're just balancing it out so that it now has a denominator. And the LCM of 1 and 8p would be 8p. One goes into 8p times. So 11x times 8p. And that would give 88 px. 8p into itself goes once. And negative 3y times 1 is negative 3y. And that's our answer. Even though the 8p could go into the 88p, we can't do that because it can't go into the negative 3y. We cannot subtract 3y from 88px. We just can't. They are different terms. They have different variables. So there's nothing more we can do to simplify this fraction. This is as simple as it gets. So let me hear if you're understanding now. So Aiden, you're saying the LCM was 3p and 1p. The 1 didn't have any p. So you're finding the LCM of 3p and 1. The 1 didn't have any p on it. So we're going to do 3 more. So number 8, we have x over 5 pq plus 2p over 3x. So for number 8, what will be the LCM? What's the LCM for number 8? We have x over 5pq. We have x over 5pq. And we're adding 2p over 3x. So I want you to tell me, what is the LCM? What are we going to put under the line? So Sajarta says he understands, and Najara says, I got it. That's great. That's great. What's the LCM? All right, I'm seeing some answers coming in. Yes, seeing some answers coming in. Yes, good, good, good. All right, so the LCM of 5pq and 3x would be 15pqx or xpq, preferably in alphabetical order, right? So 15pqx, that's the LCM. So the LCM of 5 and 3 is 15, and we have to represent each variable. So it will be the p, q, x. So 5pq into 15pqx. The pq's will cancel, leave x. 5 into 15 goes 3. So what we have carried up here is 3x. So let's do that again. The 5 into 15 goes 3. The PQ cancels that PQ, so we're left with x. So x times 3x, that's going to give us 3x squared. And the 3x into 15 PQX. 3 into 15 goes 5. The x cancel the x, so we're left with PQ. So we're multiplying 5 PQ. So 2p times 5pq, that's going to give 10p squared q. Because p times p would give the p squared, and then we have the q. So let me hear from Makaelia, let me hear from Ngozi, let me hear from Lejande. If you get it so far, we have 2 more to go. So those persons who said they weren't quite getting it yet, let me hear from you now. If it's any clearer to you at this point. And if not, which part of it is still not clear to you? All right, so Makaelia is saying she gets it. How about you, Gozi? Still got it. All right, Najara says still got it. So we're just reinforcing for the ones who know that them understanding now, you know you got it, you got it, you got it, you got it. John said he got it long time. 10 years ago, John get it. So we're going to now do 2 more just to reinforce. Ajabalani is saying how we got the square. So I'm assuming he's talking about the 10p squared. So the 3x into the 15pqx. So that goes 5 times, and then the pq's cancel out. Sorry, the x cancel out. So we carry up 5pq. So remember, we had a 2p at the top up there already. So when that 2p multiply with the 5pq, the 2 p's times each other would be p squared. That's how we get the p squared. So let's do 2 more. So that's going to be number 9 and number 10. Okay, so for number 9, we're going to put 6 over 10 xy minus 4 over 15y. So the LCM of 10 and 15, we know that's 30. And we're going to multiply, so we're going to represent the xy. So that's 30xy. 10xy into 30xy, that goes 3 times. So 6 times 3, that's 18. 15y into 30xy, the y's cancel. So that y cancel that one. and 15 into 30 goes 2. So we're carrying up 2x. So negative 4 times 2x, that's negative 8x. And if we look at these, we see that they can be reduced, right? Each of these terms is divisible by 2. 2 can go into that, 2 can go into that, 2 can go into that. So we'd be left with 9 minus 4x over 15 xy. And that's our answer for that one. So let's do the last one now. And that's going to be number 10. All right, so for number 10, 25x over 40 w minus y. All right, so what we're going to do for this? What's the LCM? So we know where to put that over 1. So the LCM would be 40w. 40w into 40w goes 1 time. And 25x times 1 is the same 25x. 1 into 40w goes 40w. Negative y times 40w is negative 40w y. So looking at these terms, we can simplify it by reducing the coefficients using 5. 5 goes into 25 5 times, so that's 5x. 5 goes into 40 8 times, so that's 8wy. And 5 into 40 goes 8 times again, so that's 8w. So that's as simple as that one gets. And that's the end. So Legende is finally saying it's a little clearer, but not all. So what Legende can do in her spare time is to just watch over the video. Just watch over the video from start to finish and practice. So you can stop it just before the answer and work it out and see if you get the answer as you go along. But that's the basics of it. It's just like any other fraction. You find the LCM and you divide the LCM by each of the denominators. And when you get that answer, you multiply that answer by the numerator and put that all over the LCM. And then you check to see if they can be reduced, but it has to be a common factor to all terms. If you can reduce it, reduce it. Remember, you can't add or subtract terms that are not alike. And that's it for addition and subtraction of algebraic fractions.